All right. Hi, everyone. Happy Friday. This is Kristen Palazzolo, Community Manager for the CA Security Community. Today is the final webcast in our Summer Lunch and Learn series. Don't worry, we have more great webcasts coming up, but this is the final webcast in the Summer Lunch and Learn series. Today we will be hearing from Steve McCullough. He'll go through his slide deck today on today's topic, and then Sean Croswell will be doing a live demo. And then after Sean's done demoing, we will open it up for Q&A. So feel free to hold your questions to the end, or you can ask your questions while they're presenting in case you don't want to forget. You can just enter them in the chat panel or the Q&A panel, and I will be more than happy to ask Steve and Sean at the end of their presentation. Today's webcast is being recorded. I will follow up via email with everyone who attends today with a link to the slides as well as the replay video. And if you haven't already, make sure you follow the CA Security Community, which can be found at ca.com/talksecurity. So I'm going to pass it over to Steve now. Thanks again, Steve. This is your sixth one, and we can't wait to hear about today's topic.
Thank you, Kristen. Hello, everyone. This is Steve McCullough, and as Kristen said, this is the last in this series, but more will follow. Sean Croswell is our subject matter expert for this particular topic, and we'll be doing an in-depth demo as soon as I run through a little bit of level setting. Again, we've been talking about privileged access management for this entire series. This particular one has some content that you haven't seen or heard about in depth in the other sessions that we've held during this series, and he'll be demonstrating some pretty exciting features for us when we get to that part of the presentation today. So the business case for CA for privileged access management, which a lot of our customers are coming to CA to help them with, is for additional defense, part of a defense in depth strategy really, for controlling and preventing breaches. Privileged accounts are on the critical path, as this quote from Forrester Research indicates. So the kill chain of an attack always includes abuse of privileged credentials. For that reason, a countermeasure for the attack is to put strong controls around those privileged accounts, where they can go, who can use them, audit them, and so on. The breaches that we're highlighting here are some of the more famous ones. You all could probably keep this particular slide updated with the news of the week because they're continuing, it continues to be a very serious problem. Privileged accounts are ubiquitous, as we've talked about before. The legitimate use of privileged accounts is that of which to perform administration, system administration, network administration, database administration, and so on. Every system, every application, every platform has the concept of a privileged account or a privileged role or sometimes dedicated privileged identities. And that's for the purpose of performing administration so that regular users are prevented from exercising those capabilities. But somebody has to keep these systems optimized and patched and so on, and that's the job of the administrators. So they use privileged accounts to give them the authority to do that. Along with that authority comes the potential for abuse. So I bypass normal security controls as a system administrator, but I may also use that privilege now to either intentionally or unintentionally perform either a misconfiguration or perhaps theft of some intellectual property. Those privileged accounts are also targeted by attackers, and that actually is a larger focus of concern these days because if I'm somebody on the outside, I want to become somebody on the inside. And while I'm on the inside, I want to get as much privilege as I can so that I can get past the standard security controls and steal your intellectual property or whatever that my particular goal is. The motive is often different on the attacker. Usually it's financial, though, and the techniques are all the same, really, regardless of whatever their motivation is. You see depicted on this slide that there is the on-premise systems, and no doubt this is a very important part of probably got a lot of very important data and a very important environment to secure. So those on-prem apps even those that are done in a virtual environment such as through VMware, need to be controlled through privileged access management. But very often enterprises now are puncturing holes through their exterior defenses to open up to infrastructure as a service, software as a service, remote access to partners. When you open these up, you also have the potential for getting attacked by a hacker who may attack you directly or could perhaps attack a partner that you are allowing trusted access to. And of course, malware is a programmatic way of planting and exploiting whatever privilege they're able to achieve. There are a number of things that, with regard to securing the cloud, could be done. In particular, today, we're going to be taking a look at AWS. We can also support and provide controlled privileged access to SaaS applications, such as Office 365 and so on. But our particular topic today is going to focus on Amazon AWS, and Sean, as I mentioned, will be doing a deep dive into that in a little bit. The goals of privileged access management are the same regardless of the environment. Really, you want to address the entire hybrid enterprise, not just your on-prem systems and applications, as was depicted on that last slide. Some of the countermeasures that we're going to implement include strong authentication, the credential management or the credential vault, a zero trust model based on a least privileged role-based access control, the command filtering that we have looked at that provides a whitelist and blacklist type of command with command control through an agentless approach through the Bastion host that CA Privileged Access Manager sets up. Video session recording to increase people's accountability and also to alter their behavior, and the ability to extend credential management out to various applications. These are all topics that we've been covering in depth over the last several weeks of this series to achieve these business goals of compliance, risk reduction through stopping targeted attacks and insider threats, and again, focusing today somewhat on the hybrid enterprise, in particular infrastructure as a service through Amazon, and being able to enhance or improve operational efficiency. So you don't want to make it too hard for people to do their job while you're implementing these controls. So to manage risk, again, the kill chain always consists of an initial entry point, privilege escalation, wreaking havoc. And there are a variety of attacks that are on the surface that can be exploited, from password management to lack of authorization, lack of good authentication, lack of monitoring, lack of auditing so that you can't see that it's happened. Once they've elevated privileges, they're always going to do this expand model to try and get a permanent foothold, as if you will, put in backdoors they can exploit more easily later. And then once they have control of your environment, they can wreak havoc, as the typical MO for this. So the countermeasures that CA Privileged Access Manager implements include the enforcement of strong authentication of your own choosing. CA Advanced Authentication is one, but any form of authentication that you want to apply, we will support, as well as other login controls and application type of controls through the credential vault. Other control countermeasures that we provide are, going to include the zero trust model. That is, you get denied access to everything except what you're explicitly permitted for based on your role, automatically logging you into the endpoints, perhaps using a single sign-on, just an automated login to the system that we're controlling access to. The built-in agentless command filtering, the leapfrog prevention to keep you confined to a particular server that you've been authorized for, and the detection of violations to the leapfrog and command filtering policies that are all done inline and allow you to take automated response when you detect these conditions, somebody trying to run these breaches. Excellent logging of who has done what, who used which account, who accessed which systems, the warnings to the users, perhaps automated session termination if they run afoul of a particular set of policies, alerting to administrators. Some of that is done through built-in integration with Seams that we've already illustrated. The video session recording is a very important and built into our product, very easy to implement feature. So you can get video session recording not just of a subset of your enterprise, but the entire enterprise. Every privileged access, if you're controlling access to the credential, that means you want to hold people accountable. The video is the way you do that. So it's really an important feature that should go hand in hand with every feature that you implement as a countermeasure through privileged access management. Again, integration with SIEM and analytics, and tying this back to particular named users. Who was that who used the root account? Who was that who used the Oracle account? You want to be able to hold people accountable for their actions and to see everything that they've done. At the same time, you're preventing unauthorized users from using those accounts in the first place. CA Privileged Access Manager is built on a purpose-built appliance-based form factor that can be physical appliance, a virtual appliance, or an AWS appliance. So here you start to see in our integration with the cloud that the product itself actually can be cloud hosted through a purpose-built appliance that deploys as an AWS AMI. And when you implement it that way, all of the same features are available to you for your traditional on-prem data center, virtual data center, as well as public cloud. So you can implement CA Privileged Access Manager as a bastion host, through which it's kind of a broker, a middleman, through which access is controlled for protected endpoints. And regardless of whether you're using the hardware, the OVA, or the AWS implementation of that appliance, all of these features are available to you. And the appliance comes with the built-in operating system, the built-in database, built-in load balancing, active-active, high availability. So it eliminates a lot of the hidden costs, and also it's very massively scalable. So you can turn on all these features, the credential vault and the session recording, for example, on the entire enterprise, and still have the ability through only a pair of appliances to record thousands, maybe 5,000 concurrent recorded sessions. If you need to increase beyond that, you can add another appliance to the cluster and scale linearly as you add more. And regardless of the form factor that you use, the ability to support infrastructure, AWS, is supported. So you can have an AWS implementation of CA Privileged Access Manager and manage your on-prem data center, as well as the other environments. You can have an on-prem hardware or virtual appliance or cluster and still have exactly the same capabilities to manage the infrastructure as a service platforms. So it's a very simple, very scalable, full-featured solution through the purpose-built appliance. Last week, we took a look at Privileged Access Manager Server Control. It's a product that CA has had for a long time, and we've always been a leader in that space and provide the gold standard for server security, Windows, Unix, Linux, and provides mainframe strength security on those platforms. And through the addition of Privileged Access Manager now, in sort of an 80-20 rule, Privileged Access Manager provides that bastion host, man-in-the-middle protection for to give you all of those controls that we were describing across your entire enterprise. And then for perhaps a 20% subset of your environment with the really high-value mission-critical servers, you may wish the additional protection of the host-based Privileged Access Management Server Control to provide a nice defense and depth strategy for privileged access management. In particular, where we're going to go with the presentation today is we're going to take a deep dive into the Amazon AWS capabilities. And as I mentioned, it can be implemented as an AWS AMI. So the appliance itself can be hosted in the cloud via Amazon. You can use it to discover through an integration with AWS the AWS instances or the virtual systems, if you will, that are hosted in that cloud platform. It has the full featured support for all of these EC2 instances. So every feature that I've just been describing, those capabilities are available to control access to those systems that you are hosting in the cloud. And the really, really slick implementation of AWS Management Console APIs. There's when you implement virtualization, you've got a concentration of risk in the platform itself. So consider VMware. If somebody would break into the VMware hypervisor, they could compromise your entire virtual data center. And the risk is compounded in Amazon, in AWS, because it's hosted on the internet. You have even fewer physical compensating controls when it's cloud hosted than you had. So you actually have a multiplying effect of risk. And there's, again, this concentration of risk in the AWS platform itself. If somebody can compromise your AWS console, then by definition, they would compromise whatever data center you have hosted in that cloud. So securing the console itself, providing API-level role-based access to the administration of AWS, gives us a real powerful depth of control, and Amazon really is unequaled in the market. I think at this point, I'm going to pass it back to Sean Croswell, who's going to be driving the demo today. Sean came to us from the Expeedium acquisition last summer. So he was one of their star engineers at that company when we acquired them. And prior to that, he was actually a customer. So he often tells the tale that, do you remember the electric razor commercial from decades ago? Hey, I like this razor so much, I bought the company. Sean actually is in the boat where he liked this product so much he wanted to work for the manufacturer of it, and that's how we were fortunate enough to get Sean working for CA today. So, Kristen, I'm going to pass this back and let Sean drive the demo at this point until it's time for questions.
Yeah, great, thank you. I just passed it over to Sean, so Sean, you should be able to share your screen now.
Thanks, Kristen. Thanks, Steve. And thanks, everybody, for joining today. I'm Sean Croswell out of Charlotte, North Carolina. And Steve said I've been with this product for several years now, and it is a true story that I spent most of my 20 years in IT as a consultant. Vendor agnostic, looking at lots of different products and webcasts like you're watching today. And then I ran across one that just totally sold me, and not only did I recommend the customer purchase the product, but I asked to join the team. So very true story. I'm sharing my desktop now. You should see a web browser here. Looking at my Amazon EC2 console, all of the devices that I have in this environment. There's 22 devices here. Bringing up this console for two reasons. One, to show you where we're going to do this product demonstration today and what devices I have there. But second, and most important, to show that the cloud virtualization adds a lot of convenience to what you do, because these aren't physical machines that you're paying for power. You're racking and stacking in your physical data center. They all live in the cloud, but it's also going to add a management overhead. Instead of going to a physical device, you're going to go to a console and do your actions from there, your administration and your maintenance. You're also going to have to make these devices routable. So, your customers, your users, your administrators are going to have to get to these devices. And that could be either putting a public IP on these machines, these devices, which, then opens it up to the world, or private IP and having to do some routing and, some VPN there so that we can get to those devices. That data center, that virtual data center is going to be separate from your physical devices, from your virtualized, your VMware setup. So, for a user, there could be different access methods, more overhead on the end user. And then for your administrators, there's having to go to, a whole separate management console to get to these machines to perform, your AWS management functions on these machines. So you'll see here that, this is only one routable IP, and that's a firewall that I have in here. And I'm using that to help secure these devices in the cloud, again, to not make them publicly accessible to anybody on the internet who goes to or browses to the Amazon cloud. You'll see they all have private IPs here. They have a public IP, and the way I'm securing this environment is, I've got I would go to this public IP, and then I'm natting all these other appliances behind it. So very hard to perform a scan, network scan to see this environment. Very hard to get access to it unless you've been given, specialized access to this environment. We've got about 20 minutes to do this demo. There's a lot more we can do in AWS and with PAM itself than we can cover in 20 minutes, but I want to make sure, we allot time for questions in at the end. Obviously, if you're subscribing to this series, you know the need for privileged access management. If you look at the breaches since 2011, 93% dealt with, compromised privileged accounts, either by spear phishing, or phishing emails to get those privileged accounts and then get in the environment, move around laterally, see what else they can get to elevate privileges. So, one thing PAM's going to do, a privileged access management solution, is take away those credentials from the end user, from the admins. You'll be managing them within, PAM. PAM will be doing the management, so the users won't have those credentials to give away. And with CAPM, those credentials could be the username and password, or it can be SSH keys as well. We keep them all in the same FIPS 140-2 certified vault. And we're talking about AWS today, but with the physical appliance, you can even go to FIPS 140-3. So I'm going to do everything from the browser here. You can access CAPM via the browser. We do also have a client. It was a feature request that we added last year. It's an executable, or you could do an install, so you have it in the machine itself. But one of the things that I really liked about CAPM is that you don't have to push out software to the user's machine to get into the environment, to get into CAPM. You can simply connect via a web browser. We accept multi-factor authentication. Is another way we can take the overhead off of your administrators. Usually with multi-factor or second factor, there's software you're going to have to put on all your servers. So, to do multi-factor here, I would have to install, usually and typically, multi-factor software on every one of these instances. With CAPM, because of the way we integrate with multi-factor, we do the multi-factor, we do the authentication here. So it really simplifies management of that environment for your administrators. And I'm going to log in here as a user to show you what the user would see. I'm going to use the local credential database here. Okay, so CAPM is going to bring up my access policies. You'll see a list of the devices that I have access to and what device methods I have. So again, these devices are all in AWS. To do this, I did not have to connect to AWS. I did not have to fire up a VPN, or use any AWS software, but I'm still able to see all the devices here. I've got my access methods, so these are applets that can be served up from CAPM. The users wouldn't have to have any software installed on the local machine to access these. Should the users want to use PuTTY, Secure CRT, PowerBroker, PuTTY or anything like that to, like they're doing today, they don't want to change when they go to a password management system, we can facilitate that as well. So, you've got the access methods here where you can go into PAM without having anything installed on your local machine, or we can also support a local installation of PuTTY to go in the machine here. Zero trust model, so you can see again, there's 22 instances here in Exedium in Oregon here. But zero trust, D-Adams only has access to the devices that have been given in his access policies. We're here to talk about AWS, so let's look at how we would come into AWS here. You see I've created a link for my AWS Management Console. I'm going to go ahead and click on that link, and PAM is going to fire up and facilitate that connection. You're going to see that it's the same web browser. I'm sorry, the same console you can see in the other tab of my web browser here where I'm logged in. And actually, I'm using the same account. So the same account that I logged in with here in the first tab is the same account I'm using for D. Adams to log in. But if you look at the top, instead of the owner or my S. Croswell account, you'll see that it's D. Adams. So because we're coming in through the API level, even though I'm using the same account to log in, I've got full attribution to the user that's using it. You'll also see that this session is being recorded. You're not going to install an agent on your AWS Management Console, but because we can do most everything that we do without having to put an agent on the target device, the target web portal, you can still monitor these sessions, record these sessions. So this session is being fully recorded. And I can go in based on whatever role that I've assigned to this account, and I've given it the full power user account. So I can come in, I can see my running instances, I can do whatever I need to do. And of course, AWS has got a little warning pop up here, but I can come in and see my instances, launch new instances, whatever D. Adams would need to do. Let me close out of this. And that's because I gave D. Adams that role. I'm going to log off here, and I apologize for jumping through multiple accounts, but I want to show you as much as I can as quickly as possible. I'm going to go in and log in as myself and take a look at the access policy we used to come in and for D. Adams to go in and take a look at the AWS Management Console. So if my access policies load up, this one happens to be on top here because I'm just moving it. You'll see when I set up the service, the AWS Management Console, you can see the account I use, so STC admin. That's the same account that I log in with to AWS. So again, in the first tab, but I can assign which AWS role I want here. So if I was to take away power user access, which gave D. Adams everything they wanted to do, and just say IAM user access, I'm going to save that policy. Notice I didn't change which account I'm using. Why is that important? Let's think, you're already managing your accounts in AD and CAPM or your LDAP directory service, and CAPM can integrate with those. So, D. Adams logged in using a local account. D. Adams has no account in AWS. This could have been an AD account. So D. Adams could have been logging in from, an AWS Users OU or security group in your Active Directory or LDAP directory service, and we can sync up with that there. But you don't have to give accounts for your users in AWS. So again, instead of having an additional layer of management with that cloud-based management console, we can do it all through the API, through CAPM, and take that management overhead off of your administrator. So now I changed from the full power user to just the IAM user, and I'm going to log back in as D. Adams here. The same access policies are going to show up, but remember we changed which role D. Adams was using, so that's going to limit our access now when we go in. So I'm going to click on AWS Management Console, and while that's loading up, again, I'm in Charlotte, North Carolina. All these instances, the CAPM device I'm using, and all these instances are on the West Coast in Oregon, so we look like a proxy, we look like a jump box like the software solutions out there, but we never break the user's connection. And because we never break the user's connection, we're not adding an overhead or a layer of overhead on these sessions. So you're really not seeing a delay. I'm in the home office today, so it's not a corporate internet link. I'm just using my home office here, and you're not really seeing any delay as we go to these. And that's because of the way CAPM works. Also, not having that overhead allows us to scale ridiculously well. One CAPM instance, and this happens to be a cloud instance, but whether it's a physical appliance or a VMware OVA, can scale and handle up to 2200 to 2500 concurrent connections. And those all being recorded. So, because we're not a typical software-based solution that resides, on another piece of hardware on top of a third-party OS, we're not adding that overhead there. It really makes things better for your end users because they're not seeing delays as they type or any of those type annoyances. So you'll see back in the AWS Management Console, it still shows as D. Adams, even though I'm using that STC admin account. You know the user that's logged into PAM, that's being recorded. And now we'll jump into EC2 here. Remember, we've changed the access at the role level. So I'm going to jump into my EC2 instance, and now I'm just an IAM user. So when I go to look at running instances, if I go in to make any changes or try to launch any of these new instances, PAM is not going to let me do it. I can see what's here. So, you know, because of time constraints, as I was logged in as the power user, I didn't launch any new instances. But now if I was to try to launch an instance, it's not going to let me because I'm in just as IAM role. So all I would have the ability to do, I'm read-only for everything else. So I can see what's in an S3 bucket. I can see what's in the running instances, and we can even take that away so the user can't even see those. But all I would be able to do is to come into the actual ECT group for IAM and make changes there. And again, you're fully recording that session, and when we look at the logs, we're going to fully attribute all these actions back to D. Adams. So just a quick demo on how that works. I'm going to log off here one more time and log back in as myself, which would be a global administrator. It's role-based access, so even though it's a zero trust model, if you want to assign a user group or, you know, import and sync to a OU or security group in your AD or your LDAP, you can base all your user access off that. So you can have a user group called AWS Users in AD. You know, and as you add and remove users from that group, they would be automatically, you know, provisioned for access to AWS in PAM or have that access taken away. So again, taking a layer of overhead off of your administrators. So how are we connecting to AWS? I'm going to go into the config menu and show you here. So I'm going to go into config and third party. And I'm going to scroll down here to AWS. And you'll see here, using that same STC admin key. Again, it's still going to show the user. It was D. Adams when D. Adams logged in and used it. But here's where I can connect to any AWS region. If you work with FedGov and you use the FedGov cloud, we can also integrate directly with Amazon's FedGov cloud. So it helps you if you're not fully FedRAMP compliant. You know, our device is Common Criteria EAL version 4 plus certified by FedGov. So you can use CAPM to access the FedGov cloud. We can integrate directly with there. You see I have a refresh interval here. So if I did go in and launch a new instance here in AWS, in this region, I've got the AWS refresh interval set for 15 minutes. So within 15 minutes, PAM's going to refresh and automatically pull in that new instance. There's multiple tags. You know, we can work with the AWS tags, so you can, you know, pre-name and do some pre-policies for that based on tags. And you can also do multiple AWS environments. So here's another case where end user, say you've got multiple, you know, maybe you're an international company, you've got your US West here in North Carolina AWS EC2 environment that you're using, but you also have some in Ireland. You could simply add those, the EC2 instance for Ireland here. Your end users would not have two different subnets to go to, you know, if you're using different IPs for those devices, so they wouldn't have to worry about using maybe, you know, one VPN to get to the devices in Europe and one VPN for the devices in the US or in this US West region. PAM's going to do all that. So the line I like to say is we separate authorization from access. So we're going to positively authenticate your users to CAPM, and then the access is going to be provided based on their policies. We're doing all the access on the back end. So, you know, your users, they're going to see the devices in whatever EC2 region they may be. And this can be your physical devices, your VMware devices, and it doesn't matter. This is, we're using an AWS Omni, you know, cloud image for CAPM here, but the physical device can do the same thing. A VMware instance can do the same thing. And for your end user or your admin, they're not going to have to worry about logging into different regions. We can do the same thing with domains. We're talking about AWS today, but say you're a company that does a lot of mergers or acquisitions, so you still have a lot of legacy domains people have access to. And we know how that can work where, okay, when you're logging into this machine, use the drop-down box and say you're in this domain, that domain, which can be, it can be a pain, quite frankly, for your end users knowing where to go in. We're going to handle all that in PAM, from the configuration here. So for your end users, they're just going to see a list of devices or web portals, whatever they have access to, network devices. They're going to see a list of what they have access to, and they don't have to worry about which domain it's in. You don't have to worry about when you add new machines to that domain, bringing them into CAPM. We can automatically scan for them. You can do them via the OU or security group. So when you do a refresh, we can set that refresh interval there, so that's automatic. They're automatically going to show up. So again, taking a lot of management overhead off. Let me go back to the administration console here. Another benefit when you're talking about cloud devices, a lot of times you're going to do access there, not necessarily via username and password, especially with Amazon. They like to use SSH keys. SSH keys are great because it's going to give you another layer of security, but management of those SSH keys can be a nightmare. And if you look at some of the hacks, maybe an RSA type hack where a machine was compromised, the user's machine was compromised, and it happened to have a lot of SSH keys on it, which gave the people that compromised the box access to machines. Because we're going to store and manage the SSH keys within CAPM, so it's going to be in our credential vault. There's no need to have the SSH keys on the user's machines anymore, so you don't have to worry about a compromised machine giving away the keys to your kingdom. Those SSH keys are still going to be securely stored within PAM. Also, it's going to take management headache away. If you're going to have these keys, somebody's going to go in and generate a new key and then pass it out to everybody every 30 days or 45 days, whatever your rotation policy may be. PAM can do that automatically. And again, because PAM's going to generate the new key, put it on your cloud device, even on your physical device, and do all that management there. So you're not going to have to worry about pushing that out to the end user. Let's take a look at one more piece here. You'll see a new tab just opened up. All management to PAM is under a single pane of glass. This was a purpose-built product from the ground up. So all management's under one pane of glass, and it's role-based. You saw when D. Adams went in, D. Adams only had his access policies there, and then his My Info, where he can go in and customize his applet. So we can say with a certain font size and his console applets or certain RDP window size when he goes into RDP type sessions. But that's all D. Adams could see. When I'm in now as a global administrator, I have access to all management functions. Well, we can do delegated access. So if you don't want to make your network admin, you can make him a global admin, him or her a global admin, but you don't want them to have access to, the Windows servers or your Unix servers or your mainframes. We can do what's called delegated access. So we can lock, even though it's a global admin, we can lock them down to certain target groups, certain target devices or device groups, so they can only see what they have administrative control over. So we can do delegated access there. But as a global admin, I can come in, I can see my sessions, so my logs and recordings, services, users, devices, very intuitive interface. What you need is, you can see it right in front of you and you go there. But second tab will open up for password administration. And if I want to go in now and look at the AWS credential accounts here, you can see the access key. You can't see my secret access key. That is vaulted within PAM. But here's how I would connect to that environment. So here's where I'm putting that in to PAM. Even this key can be rotated. You can come in. I could come in now and do a manual rotation by just simply generating a new key and then uploading that to, or hitting save, and it's going to upload to a device. I can do it by the access key or the EC2 private key, so I can do that. Or I can say, every 7 days I want this key to be rotated. I can do it as quick as every 1 minute if I wanted to. quite aggressive. But why is this important? This AWS account credentials, the key I'm using here is an administrative key, STC admin. So, that again, that's the keys to your Amazon kingdom. If you look like a company like CodeSpaces, which was a great company, did, code storage within AWS, they had this key compromised. And the attacker was able to take control of all their devices and demand ransom, which they did not want to pay. They tried to go in a back way to take away the hacker's access. He caught them and deleted everything they had. So this is a successful company that literally just over 24 hours had to lock the doors. So that's why, these are very important. And again, these are going to be stored not on a user's machine anymore, not on a server. You can, but you don't have to. They're going to be stored in our FIPS 140-2 vault. And again, you can even go to FIPS 143. We've got about 3 minutes here. So what I want to do is go over to the main window here and show you some logs. One thing we did not have time to get into today because it just takes more time is the way we can be an AWS API proxy. So this is standard access for your administrators or users where they can come in for privileged accounts and do what they need to do in AWS. But we also connect as an AWS API proxy. So if you're automating a lot of your AWS, bringing up machines, changing security groups, you can use Puppet or Chef, whatever you may be doing with the AWS API proxy. We can serve as the host for that proxy. And what that will give you is instead of having a single key or 2 or 3 keys that you use for your AWS API management, and maybe it's a key for the sake of overhead and not being a management nightmare, it's an admin key or a key that can do a lot of things, but you're using it in simple API calls because it's just too much work. We can, again, we're doing this through the API level on our side, so we can delegate that access and we can say that AWS API key, even though it may have full admin access, when the commands, when the requests are coming through CAPM here, we can limit what those can do. So you can still have that one account for, ease of maintenance and overhead, but you can have CAPM delegate what it can do. So the same key that could, do everything from spin up new instances to delete instances can be limited to only pull down shares from an Amazon S3 share, or only make a new role in AWS in the IAM. So make a new IAM role, and that's all it can do. So really cool things we can do there. The other thing is we act as a central point of logging for all of that. So we will log all those calls. You will see which user in your, your AD or LDAP user in your environment invoked that API call. So full accountability and attribution back to the user that did it. It'll show which account they used, again, to log into CAPM, which account they used to, or key they used to kick off the API call, and then what the role that API call had. So for your auditors too, this is good. They can go in and say, hey, you're adding IAM roles here, but you're using a full, power user IAM role, admin IAM role, which you don't need to use and, wouldn't be the most secure thing to do. So we can act as a central point of auditing, recording, and logging all these. And your auditors can come in, take a look at logs. It's role-based access. There's a built-in auditor role. You can make custom roles all you want. There's 18 built in, but you can have an auditor role that would come in and maybe only see these logs. You can also do custom reports. I can come in and do a custom report here to say config. I'm going to see all the config changes an admin did. I can see these here. I can save them as a report. I can even generate this, have this report generate, on the first day of every month and then send to the audit group. So not trying to replace the reporting, but, we can act as a central point of access for your end users to their cloud devices, really simplifying how they, get access. They're not going to have to worry about which domain is it, which EC2 devices, which VPN do I have to use. We can simplify all that, all the logging in one place. And again, we can record all those sessions, so all the session recording will be in one place as well. And with that, I'm about out of time. So I'm just going to pop up a recording in the background. You can see as I turn things back over to Kristen and Steve to see if anybody has any questions. We can do a much deeper dive demo with more time. So, if you'd like to see a demo of it, contact us and, give us specific use cases even, and we can set those up and show you how you do it. So, Kristen?
Thanks so much, Sean. Yeah, so if anyone has any questions, you can enter them in the chat window or the Q&A window. You can also unmute your line by pressing #6 or *6 if you'd like to ask a question over the phone. Or if you're listening via the web audio broadcast, you can unmute your line or request to unmute your line by pressing the phone icon with the question mark, and I'll get a notification to allow you to use your microphone over your laptop or computer. So I also opened up a poll, so feel free to give us your feedback. It is a Pokemon Go themed poll, so I hope at least some of you can appreciate that. We had a question come in through the Q&A window that was asked by Tara, asking, does it mean the user relationship is many to one?
Yeah, this is a two-part question, Sean. Is the user relationship many to one, i.e. are all entitled users in Active Directory are tied to one account in AWS? My partial response was that we're providing, I said accountability, but also access control. But do you want to elaborate on that?
Sure, and if I understand your question correctly, and let us know if not. So here, I just went into, and let me do that again because I wasn't. I go into users and I manage my groups here. And here I can see what's a local group, my radius groups, and then LDAP. So these are accounts that I've imported and I sync with in LDAP. So let me take a look at ABC Vision here. This is a group I use for demos. So I'm going to import them in from LDAP, but you'll see here, these are the users in this group. So these are individual users. And I can say here, I can lock their authentication down to LDAP. So again, we try to make things easier for the end user. You saw when I logged in, I pulled up that drop down that said, hey, what do I want to use? Do I want to use CA's advanced auth? Do I want to use Radius, RSA, competitive product? Which one do I want to use to come in? To make it easy for the end users, you can lock it down and just say, hey, they can only use LDAP. And one thing I left out there is PIV and CAT cards. That's one thing we're very proud of as of early last year. We are fully able to use PIV and CAT cards now. You can also come in SAML, so Federated Access SAML 2.0, but you can see here the users here. So as I sync with that, here's the users that will be affected. When I come into individual users, I can do individual things with these users. So there's ABC Admin 1, right, from that group. I can come in and say, ABC Admin 1, I'm going to make him or her a full global admin. So that's only going to affect that one user. The others, I can come in, I'm going to cancel that out, but then I could come in and say ABC Admin 2, that's an auditor. So even though when I'm syncing with that group, while I can say at the group level, I want everybody in ABC Admin to be an administrator, a global administrator in PAM, because it is an admin group. But if this is a group that might encompass many different roles, many different types of users, I can say, you know what, that's just an auditor, so I'm only going to give them the auditor role. I think
Sean,
that's what you're asking? Yes.
No, I think what she was asking was with regard to the named user in Active Directory to the identity of the user you were using in AWS.
Oh, sure. So let me go in and manage policies there. So you get to pick that. And you can do this at the group level and say, hey, the credential source is this domain controller, and then pick which account in there you want to do with each user. But if I come down here to, let me show more so I can see a Windows one. If I come down here to Windows Server and I look at users, I can come down and say which account. So if somebody is in the users group, they're going to have access to this server called Win1. And the service is it's going to be $33.89, and it's even for single sign-on. I can say that they can use this Win1 account, or I can vault multiple. But here's where I can pick the different accounts available for RDP on that device that we've set up. So I can say I also want them to have, be able to use this admin 2 account. So I can say here they can use a local admin account, but we're also going to make available a domain admin account. And then you can put more different workflows together for those accounts. So you can say, if this user wanted to use the local admin account, go ahead and log them in. That's in their access policy. Go ahead and let them use the account. But if they want to use the domain admin account, I want to do dual authorization. So I want to say, I'm going to deny the request, but say I've gone ahead and requested authorization from a approver or to a mailing list, a group of approvers, and they're going to get an email that says this user wants to use this account, in this case a domain admin account, on the Windows 1 server at 3 o'clock today. Do you approve or do you deny? And they can approve or deny. They don't have to be logged into PAM to do it. It'll come to an email. So a laptop in a meeting or a smartphone in a meeting or at home, they can approve or deny right from there.
Great, thank you.
Sure.
There was another question that I saw come in that I'm not sure if you're able to answer about if PAM is certified to integrate with VirtuStream.
So I apologize, I'm not familiar with VirtuStream. If I knew more about what it did, I could help. But one thing I didn't bring up, because we're talking about AWS, is we do have a full REST API. So through this API, it might not be an out-of-the-box integration, and it may be because some of our integration can use what we call a generic target connector, where you can very easily customize how we do the integration. So, a lot of things we can do pretty much out of the box. But even if it wasn't, we have a full API here. So, and you don't have to be a developer to use this API. There's one thing I'm not, it's a developer, but I was able, when we released this, to come in. So with our API, this one here is to get a list of devices. I can fill out here, whatever it might be asking for, just filling out text fields. And then I'm not going to log in here, but oops, and I'm totally making these up. I know that's a real account. I'm going to say try it out. And here, when I come down, you'll see that I just got the API call for this. So it's a bad request because, I just kind of put in, just random data here. But to do that, now I get the request URL. PAM gives it to me. So there's the URL to pull that. So I can make API calls and do integration. So do I want to check out an account password? Do I want to update a password, reset it? I can do this all through the API. And with the API, same delegated access. When you generate somebody an API key, sure, can you do a global administrator that has full access to every device, every target account, everything you want? Probably not advised, and you don't have to. We can delegate that access. So when you generate that API key, say you generate it for the network administrator. He or she, you can say, hey, this API key is only good for these target devices or this device group, which is the network devices. And again, we can, that device group can be synced with an OU or security group or through LDAP to automatically populate and depopulate as machines come up and go down, taken in and out of that group. And then the accounts, you can say, hey, just these TACACS accounts, that we're using on the device, or if you've got it integrated with AD, just these AD accounts for network devices. So we can do lots of integration that may not be out of the box through the API. And again, I don't want to take your question time, but an example, PAM has been around for a while with a lot of government and military type of corporations or governments, right? So, but for the commercial space, it's just the past few years with some of these big, headline-grabbing breaches that it's really come up. So one thing about PAM is we can still provide access to even old legacy, if you're an energy company, SCADA type of devices that might have serial connections. So this is what we were doing for an energy company. They've got some older serial-based SCADA type boxes. We're doing all the account management, providing the access through CAPM, which is relatively new technology, right, or at least new in the commercial space. And then on top of that, they're connecting to through APIs with the bleeding edge, some of their IoT, the Internet of Things, different types of devices. So they're connecting 1950s type, 1960s technology with bleeding edge technology all through, API integration with PAM. So just because it's not something, listed in a marketing slide or a review, with our API, you can do just about everything. And with that, I think I saw a question pop up, Kristen. I can't see it, but.
Yeah, it looks, the VirtuStream, I did a little quick check on it here. It looks like another cloud platform. So that's one we're not certified to the level of console integration such as we just demonstrated with AWS. But if the systems that are hosted there, we would be able to manage controlled access to privileged access to those systems, assuming it's a RDP SSH standard type of operating system that's hosted in that environment.
And we can still do, it's going to be full attribution for the user. So even though, like Steve said, it's not through the API, you'll know that the user that logged in to CAPM and then use, access to that device in VirtuStream, as long as we can route to it, we're going to give you full attribution to the user, and we're going to fully record the session. And this is another case where, sure, that type of device, I'm sure you're going to be able to put an agent on for some of the software-based solutions. But think about devices where you can't do agents. Network devices, Cisco, Juniper, these type of devices and mainframes. Because we're not using an agent to do a recording and we're not using an agent to do our command filtering, we're doing it through packet inspection as they're going through CAPM. So we can still record the sessions on a Cisco router. We can make sure, we can transparently log in the user. So when your networking team clicks on, router number 1, we're going to bring up a console session to it, and we're going to use the target account that, you have assigned for that user for that box. We're going to fully record that session if you want. If they want to go into enable mode, so higher privileged mode, typically, you don't want to just give everybody the ability to type enable and automatically put it in. You want them to re-authenticate or put in a privileged password for enable mode. We can see that call through CAPM and automatically inject those credentials in. And then we can also do command filtering. So you can make a blacklist of commands. Say you don't want a vendor or contractor or junior user to replace the running config with a new config they just did. You want a second set of eyes on this first. You can block that command. So when they try to enter that command, you can have CAPM say, that's not allowed, that's a violation. And then you can even say, after X number of violations, I want to go ahead and, terminate that session, or I want to disable that user's account in PAM, and they can't go back into PAM until they explain their actions and why they need their account reactivated.
Yeah, so the other questions that came in, we got one from Marcus that asked, the tasks recorded in the log, are they exposed as events so they can be picked up in real time from another technology to be redirected on or reacted on? Or would we use the API interface to do this individually?
So these events are all pulled up in real time. You'll see we even record when we look at the log records. There's no access to the OS with CAPM. There's no access to the log, so you don't have to worry about users coming in and trying to tamper with anything. These logs are hashed too for tamper-proof, and these go out real time. So real time here. You can also, we integrate directly with Splunk. We have, direct integration, and we have a Splunk app. Or, we can also send out up to 2 concurrent streams of syslog. So any SIM appliance, any security appliance, syslog device is going to take straight syslog. So you can do these alerts in real time. They don't have to be violations. You can set keywords, maybe a competitor name, things like that, so that when those go, it triggers an alert, but the user's not notified. So if anybody uses this environment and goes into sudo mode, I have an alert go out. So the user doesn't see that it's being, logged on it, but I'll get a real-time alert in my Splunk telling me that the user went into sudo mode. So again, you can do keywords, you can do regex even. So you can look for, it's a high-level kind of behavioral analytics where you can say, hey, this was a credit card number, using regex, or this was an IP address using regex. I want to know it's an IP address outside of our, outside of our network. So use regex to say any IP outside of the IP schema you're using. I want to know if they're trying to connect to an outside device. Let's do an alert on it, or let's block it. So these are real time.
Mm-hmm.
And he followed up, said, great, so I can do risk mitigation based on PAM as a source?
Yes.
Okay. Another question, how does password rotation sync with AWS?
So when we set up the passwords, you've got two different things. You have what's called password composition policy. So if I look quickly here at a password composition policy, you've got a Windows policy and a Unix policy only on here. I'm saying my password link. If you've got a mainframe or a database that doesn't like certain characters, Cisco devices don't want a pound sign in there, you can set up your password composition policy. So, anything we can hit and manage that password rotation, you can set up a separate policy for. And then password rotation, great question. With a lot of our competitors, it's kind of a one-size-fits-all, where you do password rotation. You say, I want to rotate all the passwords in the vault Friday night at 2 a.m. or Monday morning at 8 a.m. Not the case with us. You can come in and do what's called a password view policy. So here you can say that when somebody uses account, so if somebody comes into PAM and clicks on one of those, so D Adams comes in, clicks on AWS, or even one of the Windows servers in AWS, that's called a change password on auto connect. I have it set to rotate that password 5 minutes afterwards. So even if the user, D Adams, had some type of zero-day exploit where they were able to get the password out of their session, by the time they got that going, I've already rotated that password, and I can say every 1 minute if I wanted to be aggressive. So you can set passwords to rotate that way. You can also set up what are called target groups. So here's where I have Unix account daily rotation. So what I've said here is, for my environment, any account that has ADM in it, because the naming convention I'm using here, all admin accounts have ADM in them, and any server that contains UNI. So I can do a subnet, I can do by a certain type of OS. Here, my naming convention has Unix in it. So any server that has the UNI in it, I'm going to rotate that password. I've set up a scheduled job, so I'm going to rotate that password every day. So I come in here and look at that password rotation job. So again, there's that target account, that target group I set up that I'm doing, the Unix account daily rotation. I'm going to have it generate a new password. We can do compound accounts, so you might still want to, although not recommended. You've got root on 1,200 devices. We can handle putting the same password on all of them, but you don't need to. But I have this happen every day at 11:03 UTC time. I have this password rotate. So you could literally have a different password composition policy for every device, and then you could have a different password rotation for every device. That's a lot. And then there's also we have a fail-safe, which we call password maximum age. So maybe you say, I want this user, whenever they log in, I want 7 days after that date and time to rotate that password. Maybe they go out on sick leave or maternity or paternity leave, and they're out for 4 or 5 months. That password's not going to rotate because they didn't log in. PAM is smart enough to know if you set this up and say, hey, they haven't logged in, but the maximum password age has gone, the 7 days, so I'm going to automatically rotate it. So multiple ways to handle it, and you can even run reports or look at a if you can set up a dashboard here, but you can have reports run. I can see where passwords have maybe not been rotated in the past how many days. You can set up custom ones here, but here I can look and I can see where these passwords have been rotated. So excellent question.
All right, great. Thank you, Sean. I think we're out of time, so I'm going to wrap this up. If you guys have any other questions that you still have for Sean or Steve, Feel free to post them in the community. Again, that's at ca.com/talksecurity, or you can reply to the follow-up email I'm going to send out later today, and I'll make sure those get to Sean and Steve. So thank you guys so much for your time today in presenting, and I hope everyone has a great weekend, and we'll see you again at the next community webcast for Privileged Access Management. Thanks, everybody.